Okay, hi everyone. Good evening. I hope all of you can hear me loud and clear. Yes. Great. So guys, today we will be discussing about one of the very interesting platforms called GitHub, right? First, I'll give you a brief introduction of what GitHub is, why is it used, and then I will show you a basic version of how you can at least get started and create your own profile on GitHub. For example, if you're coming from a non-tech background, you don't know how to use the terminal, you don't know how to use the command line interface, you don't want to write code to do these things, you want to use the user interface of GitHub to upload files and just create a repository of your own, like I've created one here. And in the next future advanced sessions that we are planning to have, we will have a more advanced version of Git where we'll talk about branching, merging, etc., etc. Okay. So I hope everyone is ready. Can we start? Yes. So guys, it will be a very basic introduction. So if you already know about GitHub, a lot of it, then this session might not be very helpful for you. You might get certain good techniques and tips. But yeah, this will be first for people who are coming from a non-technical background, who have not had a GitHub profile till now, who don't know how to use the command prompt or the terminal. Okay. So first of all, what is GitHub? Does anyone here know what is GitHub? Any idea? You can Google it. What is GitHub? GitHub is an open source version control tool, technology, platform, whatever you want to call it. But the important thing is, first of all, it is open source. So you can actually look at the code, look at the way GitHub works. Okay, that's open source. I hope everyone understands the difference. We've already had sessions where I've explained the difference between Excel versus, let's say, Linux sheets. Okay. The idea is that open source versus free has a stark difference. Free is where the tool is available to you for usage for free. Open source is when it is free, as well as its original code, its original logic is also given to you, so you can play around with it. A free tool like Microsoft Excel, if you get, or Google Sheet, if you get, you're not allowed to play with it. Okay, but open source tools, you can modify them, edit the software as well. Okay, so GitHub is open source. That's number one. Version control and code base management. This is the most important aspect and why GitHub is very popular today. Showing out your portfolio, keeping your code on it for display, keeping it ready for other people to view your work, that is just a side advantage. But GitHub was not made with that intention. Okay, GitHub was not actually made with that intention. So what about version control? Okay, let me give you a scenario. You have 500 engineers working on a project. Okay, 500 is a very small number ideally, but to reduce the complexity and give you better examples, let me say that there are 5 engineers working on a project. Engineer 1, engineer 2, engineer 3, engineer 4, engineer 5. Now, there is something called as a legacy code, or you can call it current version of the code. Whatever code exists right now, okay, whatever code is already being used. Suppose you go to the platform facebook.com. There is a code written so that facebook.com runs. Right now, when Facebook runs, it runs on a current existing version of the code. Let's call that legacy code. Legacy code because this is the past. Now we are trying to create the future. Now, engineer 1 wants to write some code, and then this new code will be used as the current version. That means it will be deployed to production. Deployed to production. That means earlier, whatever code was being used, now this new code will be used. Okay. Engineer 2 also wants to do the same thing. and engineer 3, engineer 4, engineer 5. All of them want to do the same thing. I hope this makes sense. All of you. Now the problem is, as long as their individual work is independent of each other, that means code from E1 does not affect code from E2. As long as this is happening, there is no requirement of version control, because everyone is writing their individual code. Everyone's code does not affect anyone else. But that's the most ideal situation, and it never is going to happen practically. A lot of people work on the same code, use the same functions, change those functions for their usage, improve some new code, add some new incremental change, add new features, add new functionalities, and so much more. When that happens, there are problems. In GitHub terms, these are called conflicts, code conflicts. That means when E1 tried to change the legacy code, they edited some part of the code which E2 expected to not be changed, and their code, and let's say engineer 2's code, depended on that assumption. Right? Suppose there was a function. Everyone knows, everyone here knows Python. I'm expecting students from InsideAIML only today. But suppose there is a function name, right? And there is variables A1 and A2. There is a function like this. Let me go to the Jupyter notebook so that you guys understand better. Okay. Suppose there is function name and there is input A1 and A2. And let's say there is a default value 10. Okay. Now, let's say we just simply print A1 plus A2 plus A3, default value. Let's not print it. Let's return it. Okay. Suppose this is the function. Now, when E1 comes to the code, they see this function and they are saying that I need to change the default value of this variable to 20. Okay. Because the default value of 10 does not work for my requirement. I am creating a project. I am working on a feature. And for that, I need the default value to be 20. Okay. So what do? They actually update this code to 20, something like this. They just update this function. Now, if you check out this function, it has default value 20. But E1 was making changes to the code. While he was making changes to the code, E2 also comes to the code. E2 also comes to the code, and E2 says that I need the default value to be 10 only, which he sees is already 10. Okay. E2 comes to this open version of the code. This was the legacy code. I hope everyone understands this. This was the legacy code. The legacy code had default value 10. So E1 gets a snapshot of this code and change the default value to 20. E2 also gets a snapshot of this code, and based on his requirement, he just does A1 multiplied by A2. Suppose this was his requirement. Right? Now, if both of these guys push their code and update the legacy, if both of them want to modify the legacy code for their individual tasks, there is conflict. What is the conflict? Because E1's job and E2's job both depends on this function. Okay. And when they both try to modify it, there is an error, that there is a conflict in the code and one code depends on the other's code. Is that understood, everyone? Yes or no? This is where version control comes into picture. Using a version control platform, you can collaborate with multiple developers. Okay, manage conflicts and resolve them. Find multiple features and commits. Commits are basically code updates over time and analyze the code base quality. For example, if I have written a piece of code where I make changes or updates once every, let's say, 5 days, right? You also written a code and you make change once every 1 month, right? Who do you think has a better written code, considering we are both getting equal requirements? Considering we are both getting equal feature requests from the team, from the different members of the platform, the stakeholders, etc. If we are both getting equal feature requests and requirements, and my code change happens every 5 days, your change happens every 1 month, you've written a better code because you are having to make less changes and you are able to adapt with the new features. Okay. So you can collaborate with multiple developers, you can manage conflicts and resolve them, you can find multiple features and commits, and you can also isolate code changes and test them before merging them to production. So what will happen is, there is a concept called as branching in GitHub. Okay. Suppose the legacy code, okay, let's just bring back the function. Assume that this is some legacy code. This is the legacy code. When I want to make changes, let's say E1 wants to make changes, right? E1 will first take a snapshot of the current legacy code. Okay. He will first take a snapshot of the current legacy code. Okay. Then he will make changes. Default value 10 se 20 hoga. He made the changes. Now, what we are saying is E1 should be able to merge his code to main. Okay, merge his code to the main legacy system, legacy code. Okay, legacy code को हम लोग main बोलते हैं, master बोलते हैं, etc., whatever you want to call it. But let's say E1 wants to merge their code to the legacy code. Before merging, he can completely test the entire system. Automated tests हो सकते हैं, manual tests, new feature tests, etc., He will test the entire system, then merge it. So during the process of test, he has an isolated branch for himself. He does not have to merge it and then test it. He can completely have one branch for himself where he's making all the changes. He's testing the code, he's testing the system. Once he's sure that his code changes are correct, he will then push his changes to the main code. And then the main code will change. Okay. Right. So I'll give you another example of how these things work. Let me quickly show you. So this is the front end. Okay. Front end ka basically matlab kya hai? This is what the user sees. Okay. This is the, let's say, back end. Okay, this is where all the processing happens, all the database requests happen, all the features are created, used, manipulated, etc. This backend does transactions with the database, with other external APIs, etc., right? And the backend has its code. the backend has processing, which is CPUs, etc., but it also has its code, right? Now, this backend code, a lot of people are trying to change for their own individual requests. Okay. Suppose project A worker comes and he wants to make change to the code. Project B worker comes, he wants to make change to the code, right? So what will happen is each of these guys will first create their own branches. Branch project A, branch project B, branch project C, branch project D. Each one of them will create their own branches. So first what they will do, first they will take a snapshot of the code. They will first duplicate the current code. Okay, they will duplicate the current code, take a copy, take a snapshot, then do their changes, make whatever code edits they want to do, test it on the platform, test if this becomes the mainline code. Does this solve the purpose? Does this solve the problem? Once they are sure, they will permanently merge their code to the main code, so that now when another developer wants to build a new feature, they will take a snapshot from the updated piece of code, make their changes, do their tests, and then again push their changes back to the main code. Is that understood, everyone? Yes or no? Snapshot is just copy paste. Exact duplication of something. See, I cannot make changes to, I am trying to make changes, right? I'm not trying to create a new project. Suppose, आप ऐसा सोचिए, suppose you are building Facebook. Okay, suppose you are building Facebook. Now, if you get access to Facebook's code, okay, Facebook's complete code, if you get access, can you not, this might be a little stupid example, but you will get the gist. Okay, can you not change the color, change the names, change the titles, and it would look different? Definitely there is database access, there is other things, etc., right? But you are taking a snapshot, a copy of Facebook's code, and then trying to make a change, right? For example, let's say the UI UX team, okay, the user experience team at Facebook says, what if we change the Facebook, now obviously Meta, color to red? Will people like the red color over the blue color or not? So there will be an engineer who will copy the entire code of Facebook first. They will copy the entire code of Facebook first, make the necessary changes. Necessary changes means they will change the color to blue, right? Change the color from blue to red. And then he will test the platform. That means he will show it to stakeholders. He will show it to the UI UX team. Okay. Then take approval. If he gets approval on the change, he will push that change to the main branch. Main branch is the branch that Facebook currently uses live. Okay. He will push that changes to the main branch, and the changes will be live on facebook.com. Is that clear, everyone? Yes or no? Right? So every change you make, every single line of code edit that you do is a new version. Okay. So if you have gone through open source libraries like pandas, suppose aap pandas jate hain, right? In this pandas main page, can you see latest version 2.0.1? Okay. What this means is that the latest version is 2.0.1, but there is 2.0.0. Can you see the change log? What is the change log? What are the changes that have been made between this version to the new version? What's new in 2.0.0? These are the changes in Pandas 2.0.0. See release notes for a full change log, including other version of Pandas. So what are the kind of enhancements they have made? Index can now hold NumPy numeric data types. A lot of other changes will be mentioned here. Okay. So this is the change log. Someone took a snapshot of the current version and then they made the changes and took a larger version and basically released the larger version. Now, obviously, this release is not done by one people. So a lot of people took snapshot of Pandas 1.5.3, made their individual changes, and then a community, a group of people who have been actually monitoring Pandas for quite some time, they aggregated all those changes and made a larger version release of 2.0.0. Are we clear, everyone? Yes or no? Any questions? Yes. Taking the code, making the changes. Abhilash's question is, so the steps are taking the code, making the changes, uploading it back with changes. No, Abhilash, exactly वैसा नहीं होता है. You took the code, right? Then you made the changes. Then you tested your changes. Then you tried to merge your changes to the main repository. Then there might have been conflicts. There might have been things that other people, like the senior people, senior developers do not approve of. So they will give you comments. They will add comments that this needs to change. This is not right. This approach is bad. You can do this. You have to do that. Then you make the changes. Then you again test the system. So it's a very like circular process. You have to keep doing it again and again, again and again. And then finally, you don't upload the changes. You merge the changes. Okay. First, you make changes to the repository, then you make changes to the main code. Okay. Riyaz, I hope that's clear. Okay. So guys, today I'll first give you a basic introduction. Okay. When I started out in data science, I created my GitHub account. Okay. So they will ask for your name. They'll ask you some kind of, interesting, catchy name, user ID, username kind of a thing. Then you will write, you will basically give an introduction to yourself. There'll be some people following you. Abhi zero ga. It will increase over time. Depends on how active you are on GitHub. What happens is people are active before they get a job. Once they get a job, they are so busy that they are not usually focused on what should like on GitHub and these profiles. Once you get a good job and you're working hard, the job will provide you all the GitHub profile requirement. Okay. So in GitHub, there is basically each project, each individual thing that you have done is split by as repositories. Okay. So what you have to do is, suppose you have a completely new GitHub profile, you would basically create a new repository. Okay. You can give it a name. Let's say, what's today's date? 26 May 2605 2023 testing. Okay. Suppose I give this name, description, a repository to test, to display usage of GitHub. Okay. Suppose this is just basic description, right? I'm not doing anything. Make sure to keep all your repositories public unless and until it is a project that you have individually developed and you don't want to share with the world. Okay, then you can keep it private. Otherwise, mostly public license is good. Public display is fine. Add a README file. You can add a README file, which will be an empty file. You will have to later write some things into it. You should ideally have a README file all the time, and add git ignore. Right now, not needed because we are going to upload files. Choose a license. Generally, general public license version 3.0 is fine, and you do a create a repository. So everyone do that once and let me know if you guys are done. Everyone. Abhilash, everyone else who could not catch a glimpse of it, you have to go to your repositories. You have to click on new. You have to give it a name, a description. You have to add a README file. You have to choose a license. You can keep none also, but ideally a GNU license is good because that makes your repository more visible. And then you click on create repository. Okay. Guys, let me know once you are done. So we'll proceed to the next part. There's no advantage to license, Rimita. It really becomes important when you have like someone else wants to use your code, right? So can they or can they not use your code? How can they use your code? Do they have to give you a royalty, etc., etc.? A lot of things. Those are written in these licenses. So depending on the license, people who are, obviously corporate folks and high level folks, they will decide if they want to use your code or not. Otherwise, license practically has no advantage. In the initial phase of your career, surely not. Later, when you become an advanced professional, then it might help. But you'll have to read through each of the licenses. Guys, is it done? Can I move forward now? Yeah, great. So suppose now I'm in this repository, let's say GitHub profile. Okay, I'll just delete this. I'll try to find a data set. Give me a minute. Okay, so I've just gotten a data set. Okay, suppose this is a data set that I have gotten from the internet or from some source. Now I want to build a project on it. Okay, so first I will try to create a very detailed step-by-step idea for this. Suppose I will write exploratory data analysis. This is my first notebook. Okay, I'll give these names because I have to upload them to a public platform where everyone will see my code. Okay, so let's say this is notebook 1, exploratory data analysis.ipynb. I create another notebook where I am going to, let's say, what if analysis.ipynb. Suppose I create another notebook where ML modeling. Suppose I create another repository where it will be results, display, and analysis. Okay. Now see, I have to give them proper names so that they are in order. Okay. That is definitely important because they just make it more organized. Okay. Now you see that I have 4 notebooks and I have different notebooks where I'm going to write the code, and I also have the data set. So now what I will do in my exploratory data set, I will write import pandas as PD. df is equal to pd.read_csv. And then I will write video games.csv and I will do a df.help. Now, obviously, all of you know what exploratory data analysis is, what visualization is, etc., etc. Right? So suppose I created these 4 notebooks. Now, what do I want to do? I have done a lot of work. I have written a lot of code. I have given answers to questions. I have solved a lot of problems. I need to upload this whole thing on my GitHub repository so that it's publicly accessible. Right now, if I share this link with you on the chat, you can actually just click on the link and go to my place, my website, I mean, my online data platform, GitHub profile, and you can actually go through the work that I have done. Okay. So I want to upload things to my repository. Can you see add file, create a new file, upload files? If I click on upload files, it asks me to choose my files. I actually go to the exact location, select all of this and click open. It just uploads the files one by one. Okay. Once these are done, it asks me for commit changes. What is that? This is basically every time I upload new files, every time I make changes to my repository, every time I make any kind of modifications, I should always write a commit message. What is the commit message? Commit message is a way for me to keep track of why I made a change. Because 4 months later, 5 months later, 6 months later, when I look at it, I might not remember why I made a code change. Okay, so commit changes. Here I should write created the first draft of video games project. Data analysis and modeling files. Okay, commit directly to the main branch, because this is a new repository. This is completely a new repository. First time I have added it. So I will just commit directly to the main branch and I will write commit changes. It is processing my files. It is basically putting everything in my repository. Now, anyone in the world can actually, I can just share this link. They can go to my profile, GitHub profile. They can click on the things that I have written. For example, I had added some code here and they can see the same code that I had written. Is that clear, everyone? Yes or no? You can write your code, whatever projects you have done, whatever small tasks you have done, assignments, quizzes, everything. And you can upload them to GitHub for you to build a strong profile, because anyone who goes to your GitHub account will exactly know what are the things you've worked on, what are the projects that you've done, what are the concepts that you are aware of. Okay, so everyone create 4 or 5 Jupyter notebooks and then upload to your own repository and share your repository link. I will check how many of you have actually been able to create the repository, upload the files. And if you share the link with me, I can just go online and see whatever work you've done. Okay, so go ahead, everyone. Share the link on the chat for your GitHub profile for this particular project. So remember, this is the project. Okay, this is one single file. You have to share this link. Go ahead, let me know. Okay, so a lot of you are sharing. Manish, what are you not able to do? Tell me. Okay, this looks good. I can just open your file and see what work you've done. Yes, this makes sense. This is good. Yes, this is also good. Okay, so when you go to your repository, you will see add file here, upload files. Okay, try that. Has everyone else gotten it? Yeah, try to create one new and then add the README and everything. Guys, everyone else is done. Can I move forward? Guys online, yes, no? Right? Now, first of all, this is just the user side of things, right? This is an online, I would say, this is basically called a user interface, right? This is not a programming interface. You are not accessing via a terminal, via command line prompt, right? You are accessing via your web browser. Okay. Riaz, you can just do GitHub Pranjal. If you just type something like this, I think you will get the GitHub profile easily. Okay. And the same works for you as well. Now, what happens is, guys, I'll just quickly show you an example before we wind up for the day, what we are going to. So I'll just show you an example of my first, I would say, project that I did. And this was for selection of one of the internships that I wanted to do. Okay, and how I uploaded the project and showed them. Okay, so this is back in 2019 when I was in college actually, and there was a company called Social Cops. Now they are a big startup called Atlan. They had given me a data science technical challenge, right? So I created a repository. Okay. They had an entire data science technical challenge written. They had said, what is the aim? What is the idea? What are the things that I should do? What is the data that they are giving, etc., etc. So they actually gave me the data files. Okay. They gave me a basic data file. So I put all of them into a data files folder. Then all my repositories were here. You can see Python scripts. Here you will see exploratory data analysis and cleansing. Task 1. This was their task 1. Okay. Preparing data for seasonality. Then there was task 2. Then there was task 2.2, task 3, task 4. Right. So any notebook, they could actually just go on and open and see what work I had done. Okay. They would actually go through each and every code that I had written, and they would understand that, okay, this guy did this kind of, work on this particular task that we gave him. Then there were a plot section, right? So I have just clearly separated all of these into individual folders. You can go to any folder and check out any file, right? That would help you understand or analyze individual parts. So all the plots that I had created, they were because there was some reason. Okay. Something like this. Suppose I just hope an image loads up. I'll download one just to show you that it was an actual image. Download raw file. Okay, there seems to be some problem with this image. Let's see if I can get another one. The website might not be able to render. Okay, so just think of this folder having all the images. Okay, don't worry about the rest of the things. So what I've just done here is that this README also I can update, right? If you would have seen the file that I was showing you here, you can actually also update this README here. Okay, you can write a lot of things. You can add bullet points. This is an MD file, which is markdown file. You can learn how to write markdown, files, markdown text in a certain way. This is pointer 1. This is pointer 2. Okay, then highlighted value, something like this. And then I just say commit changes, commit changes. Okay, now you can see this is my updated README. If I go to my repository again, this is my updated README. So I can make changes to my README also. Then I can actually, if I want to create a new folder here, I will say create a new file. Here, I would say data folder, something like this. Okay, data folder. And if I hit a /, it will automatically make it a folder. If I just write it this way, it will basically consider it as a file. Okay, but if you write it as a /, it will make it a folder, and then you will say temp.csv. Suppose something like this, and commit changes, commit changes. Okay, now you will see that inside my main folder, I have a data folder, which I can click on, and there is my temp.csv. Obviously, it is empty. I can actually upload a file also. You can see upload files. Choose your files. Let's say I just upload the video games.csv file. Hit open. It loads, basically uploads the entire file. Commit changes. Okay, now you can see in my data folder, there is the video games.csv. Similarly, I can create more and more folders, and I can create more and more files. These are Python notebooks. I can also create Python files. I can actually just create a new file directly from here, which I would, let's say, test.py. Okay, I would write print. This is a testing script to see if files can be added from UI. Okay, I just wrote it. Commit changes, commit changes. Test.py got added. This is the code in test.py. Okay, so like this, you can actually put a lot of your projects, code bases, things that you worked on, things that you've solved, the assessments, etc., into your system. Okay, you can just put it on your GitHub profile and then just share this link across resumes to people who want to look at your GitHub profile, and they will be able to open it, check your repositories, and get started. Okay. Now, another advantage is that suppose you find someone's repository. Okay, suppose you find this repository of mine and you want to clone it, or you want to basically copy paste this. A problem you would face is you have to go to every individual file and download it. Okay. Suppose if I open this whole thing in an incognito web page. Okay. Now you will see that code, someone can download the entire zip file. That is one way. But if they download the zip file, they've not actually created any kind of linkage between my repository and theirs. If I try to make a change, their code will not be updated. That is where you should create a clone and link it if you are trying to copy other people's code, and so that when they make another change, they do a version update to their code, your code also gets updated. Does this make sense? All of you, yes or no? Okay. The idea is that you want to create a situation where if you are copy pasting someone else's code, basically copy pasting, a lot of people think that copy pasting is to steal someone's idea, but that's not the case. You might clone someone's work, take a snapshot of someone's work and make it better, make it advance. But what will happen is when you are making that advancement, you might be losing on some changes that the original repository is having. So you might be working on stale code, on old code, right? You don't want to do that. That is why simply downloading this will be not the right solution. You should clone the repository. See, it is written clone. And in the next session, which would be an advanced GitHub section, I will basically show you how we can actually do something like this. Let me just expand my screen. Okay. Suppose I go to my desktop. Okay. I create a new folder. Don't worry about the commands that I'm writing right now. Okay. We can come to that later. Git session. Oh, it's already existing. So git session. Suppose you do this. Let me just create a new file, mkdir 2605-2023. Suppose I create this. I get inside this folder, and this is a brand new folder. What I can do actually is that I can git clone. I can write the git clone command. I can copy this because it's a public repository. I can easily copy it. And now you will see it is cloning into PyData London tutorial stacking neural nets. It's downloading all the content. And now within your computer, you have the same code that I have, but now there is a linkage as well. There are commands that we will actually learn where I will show you what is a git status, what is a git initializer, what is a git branch, etc., etc. But once you initialize, you will always see that there is a status, no commits yet. That means no changes have been made. There is an untracked file like this. Let me try to enter this file. Initialize it here. Okay. I'll just clear this. Git status. You will see your branch is up to date with the main origin. Nothing to commit, working tree is clean. That means nothing has happened. Now let's say I create a new file. Suppose I create a new Python file where I just write import pandas as PD. Suppose this is the only thing that I want to write. So now you will see that there is a new file that I have created, new file temp. There were already these files in my GitHub repository. There is a new file that I have created. Now, if I check Git status, I will see that there is an untracked file. Its name is new file temp.py. Why is it untracked? Because I have not added that file to my tracking list. This is where we will also learn about git add, where I am going to add this new file temp.py to my tracker. Now you will see that changes to be committed. That means there are changes that it is already looking for, but it has not actually committed those changes. Okay. Then what we will do, I'm just sharing a flow. Later we'll go into much depth of this, right? And then I will do git commit. I have to give a message, new file uploaded, something like this. Okay. This new file can now be done git push origin, and there will be a branch that I have, git branch. Okay. Origin name. Okay. What this will actually do is it will help me push the code. Okay. So the intention, guys, is pretty simple. You have to understand that you are creating a systematic approach where code changes can be monitored. Code can be collaboratively written. Individual coders, not individual coders, but multiple people can code together. And code is being tackled in a very strategic way because there's a huge code base, a lot of people coding. Okay. So this was a very basic introduction. In the next session, we will take a more advanced session on the terminal and the CLI. I would expect all of you to put your projects and all the work that you've done on GitHub and create a profile. So before we start next day's session, I'll request all of you to have your GitHub profiles ready. So you can share them on the chat and I can go to your GitHub profiles and see if things are in place. I can give some feedback and then we can take a more advanced GitHub session where we'll do terminal and CLI commands. I hope that is fine, everyone. I did not want to discuss a lot of technical things on one place because then it will be too much information. But first build this. This will help you give some confidence on having your own profile. And then I'll teach you about what are the issues, what are pull requests, what are actions, what are projects, wiki, etc., etc. We'll cover each one of them one by one. Great. So yeah, thanks everyone for attending this session today. I will see you all in the next session. I think we have Excel planned. And post Excel, then we will have another GitHub advanced session. Basically, we are trying to give all of you time to accumulate and aggregate all the projects and Python work you've done. Create some new projects if you want to, and upload them on GitHub and create a good profile for yourself. Okay. Cool. Thanks, everyone. See you later. Have a good night. Bye.